Welcome everybody, day 2, awesome. It's great to have everybody here. Today's session, I'd like to welcome you to bringing Kubernetes container orchestration to mainframe servers. My name's Mike Friesenegger. You actually got to see me up on stage in that little keynote, and you heard me talk about this session, so hopefully that was part of the reason why you're here. But I'm not really the star of the show. I'm just kind of helping set the stage. The star of the show wasn't able to make it in person, but he is online from India. Rohit, are you there?
Yes, Mike. Hi.
Please introduce yourself.
Hello, everyone. Yep. Hello, everyone. I'm Rohit, and I work as a software engineer at SUSE. I was part of the team responsible for bringing Rancher technologies onto the Z mainframe. And also an interesting fact, I was an Open Mainframe mentee 4 years back, and I was hired by SUSE due to the same internship. So cheers to that, Mike.
Yeah, no, thank you. Thank you for mentioning that, because I was gonna say the same thing. I had even mentioned it during the keynote session. So if everybody can bear with me for just a few minutes, I'm gonna introduce a little bit of what Rancher is on what Rancher is in general and what we brought to the mainframe. And then I'm gonna play a recorded session that Rohit put together that goes in, and you'll get to see Rancher in action running on the mainframe. So I think Rohit's gonna do a really cool job in his recording, and then we'll have a few minutes at the end for questions. And Rohit will stay on to help answer questions. So let me give you a little bit of background. So SUSE has been available as an option, an enterprise Linux distribution option on the mainframe for pretty much as long as Linux has been available on the mainframe. We are the first enterprise Linux distribution. We have a lot of customers that are running on IBM Z and LinuxONE, and I talked to a lot of those customers, and I was getting asked on a regular basis, what is SUSE's container orchestration strategy? So, it just worked out perfectly that SUSE had acquired a company by the name of Rancher back in December of 2020. I think that's right. 2020? Yep, 2020. And I was able to very quickly, we had been working on a business case. I was able to adapt the business case to take to our executives and say, hey, can we bring Rancher to the IBM mainframe? Because we have customers asking for it. And SUSE always has been known for developing and innovating everywhere, whether that be on-prem, whether that be in the cloud, multiple architectures and things like that. We wanted to be able to provide customers choice. Technically, we knew it works because I mentioned that I was a mentor, an OMP mentor, and actually the first mentorship year, I had 2 mentees, and we did a whole bunch of work to test Kubernetes on multiple Linux distributions on Z, just to make sure that it worked properly. So we knew it worked. But really, the focus was, from a SUSE perspective, was to QA it, do the quality assurance, and productize it so that it could be supported as an enterprise Kubernetes distribution or enterprise Kubernetes orchestration product that customers could run on the mainframe. The real important thing, Rancher, we wanted it to be able to run in any enterprise Linux distribution on the mainframe. So you don't have to be using SUSE to be able to use the Rancher technologies. You can use our friends in red or our friends in orange on the mainframe and run Rancher on top of it. And we released on June 1st of this year. So we're actively working with customers that are doing proof of concepts and things like that. So let me tell you a little bit about Rancher and our unique approach. First of all, we believe that it's a multi-cluster world. Multi-cluster meaning that you are going to deploy Kubernetes clusters on-prem, using multiple Kubernetes distributions. You're going to do it in the cloud. That could be using AWS, AWS's Kubernetes distribution, Google's Kubernetes distribution, Azure's Kubernetes, whoever. And you could be doing it on multiple architectures, whether that be Intel architecture, ARM architecture, now S390X architecture. And really what we want to do is we want to treat all of our Kubernetes distributions that we manage with our Rancher Manager tool, our flagship product that I'll talk about on the next slide. We want to treat them all as first-class citizens because it is a multi-cluster world. It's not so much the Kubernetes distribution that makes or breaks the game for businesses, it's the Kubernetes management, it's the management of the Kubernetes orchestration. And we wanted to, and SUSE has always been known as the open source company. We're always very, everything we do is open. Everything we do is contributed open. When we bought New Vector, if you were in the session yesterday from our CTO, Alan Clark, we actually have open sourced the New Vector code because everything we do comes from open source and we give back to open source. So let me take just a quick minute or two to talk about the 4 products that we brought to S390X architecture. SUSE Rancher Manager, that's our flagship product. That is the tool, the GUI, the web-based interface that allows you to manage multiple Kubernetes distributions, wherever they might be deployed, on-prem, in the cloud, on multiple architectures. It unifies things like operations, workload management, security, all of that. We're not going to spend a lot of time on Rancher Manager today, but there are other sessions or there are other presentations that are available on YouTube and other places where you can learn more about Rancher Manager, because that is our flagship product. Rancher, when we acquired Rancher, they had a number of Kubernetes distributions. I'm going to skip over Longhorn for a second. RKE2 and K3S are 2 Kubernetes distributions from Rancher, now from SUSE. RKE2 is the traditional, more traditional Kubernetes. It is CNCF certified. It uses Containerd. It's focused on security and compliance. It utilizes the etcd database. It's a traditional Kubernetes in all senses of the word. K3S is our lightweight Kubernetes. It is also CNCF certified, but is designed for resource-constrained environments or environments where you don't want to spend a lot of processor cycles on the infrastructure software. You want to spend your processor cycles on the workload that's important to your business, to your organization. And then the last one is Longhorn. I kind of jumped over it, but I'll get back to it now. Longhorn is cloud-native distributed storage. Again, we're not going to talk about Longhorn here, but basically, when you have containers that need persistent storage, Longhorn, we actually have donated it to the CNCF, but we thought it would be a good option as an option, not the only option, to take advantage of mainframe-based storage options. So Longhorn can use DASD-based storage or FCP-based storage and present that to the containers in a highly available, replicated way of doing it. So those are the 4 products we brought to S390X. We're going to focus, and I'm going to flip over to Rohit's recording now, but Rohit is going to focus on really a number of things, and I'll let him take it from here.
Okay, so now let's talk about the dev experience in adding an extra architecture support to SUSE's Kubernetes distros, such as RK2 or K3S, and as well as Rancher, which is the management portal to manage your clusters. If you ask how difficult it was, I would say it was not so tough. The main reason is because we didn't have to change anything in the source code to make it run on S390X. Why? Because it was written in Golang, and Golang is cross-compilable. And so we are able to build all components of Kubernetes distros on S390X without any hassle. The next part is packaging, wherein the binaries that we built were put into container images and then ran. This is where we faced few hurdles. The first one being the base operating system on which some of these binaries need to be run didn't support S390X. For example, CentOS 8 So we had to choose a different base operating system which supported the architecture, and then we had to rewrite the entire Docker file. The second one being few packages required to run these binaries didn't function properly on SNNTX. We fixed some and some we couldn't. For example, the RK2 is not FIPS compliant on SNNTX. What is FIPS? FIPS is a US federal government security standard. And to make these binaries FIPS compliant, they need to be built by validated boring crypto module. And unfortunately, this module didn't support S90X. Next, we had to contribute to some upstream components that didn't support S90X. We made PRs to these repos, and these are traffic, customized kind, Nginx, and K9s, train and Trivi. Okay, so we talked about building, packaging, upstream projects, not so much hassle. The last part is integrating an architecture into our CI/CD pipeline. Uh, uh, I think it was a bit difficult here because Drone didn't support SNDH architecture, and whatever pull requests that we were making were uh, not getting accepted because they didn't have SNDX servers to get tested. But we showed them, introduced them to the open source community cloud, where open source projects could get permanent access through S90X servers, but still the response was very slow. So uh, we had to do our own hacks. Anyways, let me show you what we did. It was pretty simple. As soon as the code is pushed, the drone server, which manages different runners, assigns the task of building binaries to architecture specific runners. And right now only x86 and ARM were supported. All we had to do is to add another drone runner which supported as which is a S390X virtual machine, where S390X components could be built, packaged, and then released. So we went through how we added support for S390X. Now let's show you the result of it, a demo. And the main goal of this demo is to show how much CPU is being used by a mainframe machine, be it CPU or IO, when we run RK2 in ideal mode versus when we run K3s in ideal mode. We have chosen this goal because in mainframes, billing is done by number of CPUs. So the less CPUs we use, the less money we spend. The second reason, which is very important, is that any customer would want to spend CPUs for their applications running on the infrastructure software and not for the infrastructure software itself. So we are going to show you how less CPU usage is being done by RK2 or K3s. And the third reason is that we want to show you how easy and fast it is to install RK2 and K3s on a mainframe machine compared to other solutions out there. Okay, so let's get into some action. First, let's talk about our environment. We are using three S3NTX virtual machines, and these three machines would be used for installing highly available configuration of RK2 or K3s. And each virtual machine has Sleep 15 SP3 operating system of SUSE, two processors, and approximately 8 gigabytes of RAM or memory. We are already logged into the three servers. As you can see on the terminal, we'll be installing RK2 version 1.23.6 with Canal as this CNI plugin. So the release of RK2 versions are in parallel with the releases of Kubernetes versions. So this version that we are installing will contain the source code of Kubernetes 1.23.6 version. Okay. Before we start installing RK2, we need to define some configuration values. So this is the file etc rancher rk2 /config.yaml, wherein we define the values. For the first node, we are defining two values. The first value is the token, which will be used as a secret for other master or worker load servers to join the main cluster. Let's keep it as token, or you can put any value into it. The second value is the TLS SAN, which is useful for setting additional SANs so that there are no certification violation errors when you use a load balancer in front of your master nodes. So for now, we give the address of the first master node of the cluster, that is 10.161.129.137. Okay, we're done with the configuration. Very simple, just mentioned about the secret token and the TLS SAN. Now, before we install RK2, for SLES, we need to install a dependency that is AppArmor. But for Ubuntu or RHEL, this step is not required. Looks like it's already installed. Okay. Now, let's run the RK2 installation bash command. And copy it properly. So this is just a single bash command, and I'm specifying an environment variable for fixing the RK2 version. There are many other variables that can be defined for custom installation of RK2 for your use case. And this command that we run installs a binary and also a systemctl service named RK2 server. We just need to enable that service and start the service. Let's do it. This takes some time as it starts the necessary components of Kubernetes, and those Kubernetes container images needs to be downloaded from the internet. So this might take a couple of minutes. Successfully, let's check if it's working or not by running the kubectl command. Okay, I didn't export the kubeconfig. The kubeconfig location for RK2 is this one, etc rancher rk2/rk2 YAML. Okay, now the kubectl could connect to the cluster, and you can see it's still trying to set up pods and make them run. You can see core DNS canal, and the API server is already up, and EHZ is also up. So it may take another 1 minute, I guess less than 60 seconds to completely start the Kubernetes cluster, a one node cluster. Okay, I think everything is up now. Okay, this last one, Nginx controller. So the ingress controller is also up. Now let's try to add 2 more nodes to the cluster so that this becomes a highly available configuration. It's the same process again. We define some configuration values. This time we define an extra value that is server, because we need to tell the node how to join the first node, the first cluster, the cluster which consists of only one node right now, or one virtual machine. Okay, so it's the same commands again. Install the dependency and then run the bash script and then try to start the systemctl service. This takes some time. Meanwhile, let's try to watch the nodes here. So after some time, you should see RK2, the second node, and it should also be master, etc., and control plane, since all the 3 nodes that we are trying to set up are master nodes. So there is another node, RK2, and it's status ready. So we have now a 2-node cluster. Okay, now let's just repeat the same process again for the third node. I'll be a bit faster now because it's the same thing all over again.
Now remember, he's doing this live, not live, it's recorded, but this is real time. So you're seeing how long it's actually really taking to do a Kubernetes deployment, matter of less than 10 minutes.
After some time, we should have all the 3 nodes in ready status. Seems like we got some problem. Let's try to check what the problem is. Okay, I think the problem got fixed itself because we could see a third node being added here. And it's currently not ready status, but sure it will come to ready status soon. Okay, you can see it's in ready status, and we could see the pods here in the third node also. Now let's get into analyzing how much CPU usage does this cluster take actually. We are purposefully checking the usage only during ideal time, as in when there are no applications running, because we need to know how much the infrastructure software alone consumes. We will be using hiptop command for this. So hiptop command shows us the real-time CPU usage in percentage terms. So if you can see here, it says it's using 30% of the total CPU available in this particular virtual machine. Let's actually run this command on all 3 nodes and compare between them. Since there are 2 processors for each virtual machine, we need to halve the number that is being displayed here. So if on an average, this is showing 30, so we should say 15% of the total CPU usage in this virtual machine. And if you see the numbers for node 2 and node 3, they're always in 20s, and for node 1, they are like 30s. So we can say that the first node is using, the first virtual machine is using more CPU than the second and the third virtual machines. I suspect this is because there are more number of pods running on virtual machine 1. We can actually find out. Uh, So these are the pods running on node 1. So I ran the kubectl command with the filter saying, show me the pods running on RK1, that is virtual machine 1. And it shows these number of ones, these number of pods. Let's count them. So it says 16. And for the second one, it's only 10. And for the third one, it's only 9. So that's the reason the virtual machine 1 is taking more CPU usage. But we can safely say that around 10 to 15%, or we can take the max 15% of the total CPU available in the virtual machine is being used by RK2, that is the infrastructure software alone. So let's come into K3s. Let's try to install K3s in HA mode and then check the CPU usage. First, we need to install the dependency in the same manner we did for RK2. This is only required for SLES, not for RHEL and Ubuntu. And then we just have to run single command for K3s. So this, for the first part, installs the binary, and then we are saying that there should be a master node. Then we are giving a token, just like in RK2. And then we are telling it that this is the first node of the cluster, and we are giving a unique node name to it. If you don't give this, And if you're using etcd as the database, you would get an error saying duplicate node name. So it's better to mention node names for each of the node that you are where you're installing K3s. Okay, super fast installation. Let's try to watch if the pods are coming up. Yep, they're all coming up. Okay. Now, meanwhile, let's do it for the second and the third node. So it's the same command, no change in the commands, except that you will specify an extra parameter for the second and the third node. That is the server URL, the first node IP address in the port where it should contact so that this node can join the cluster. Okay, let's run it. And then these. And node one, let's try to watch nodes instead of pods to see if this node is being added successfully or not.
So the one thing that I didn't mention.
Meanwhile, I think we can run this command for the third node.
So Rohit is using etcd for the key store. A K3s can
So
use
this
other
service
databases.
has started, and you can see this is master node, and I think soon will be in ready state. So the third node got started. So in less than 2-3 minutes, you have K3s cluster in HA mode on S90X. This is very fast installation, I guess, compared to other solutions out there. Now let's try to run the hiptop command on all the 3 virtual machines. So you can see that it's 10, 8, and 7. For RK2, we saw that it was around, generally it was 30 here, and then 20, and then 20, but this is way less. So on an average, I think this would be 10 to 15. So as I said, there are 2 processors, so we need to half it. And so it would be like 8, 9% of the CPU compared to RK2 servers usage. This is way less. And for the node 2 and 3, it is even more less. I think it's the same reason that we checked for RK2. The number of nodes on the number of pods on node 1 are higher than 2 and 3. But let's just confirm that. Very simple. These are the nodes. There are 8 nodes here. Here. And 2, there are just 2 nodes. And in 3, there are 2. So makes sense. The pods in 2 and 2 second and third virtual machines are very low, so it uses less CPU. So if you want to have less CPU usage for your infrastructure software, then RK2 and K3s are, I think, the best out there. Or K3s is even more lesser because it's designed to be installed at remote locations where CPU, there are constraints on resources. By this, I'll hand over to Mike. Thank you for giving me this opportunity to demo an Open Mainframe Summit. Thank you.
All right. So thank you, Rohit. That was an awesome demo. Just to summarize what you saw there. So RKE2 and K3s are 2 different Kubernetes distributions. RKE2 took 30% of the processor on node 1. K3s took much, much less than that. So we want to give customers the choice depending on what their utilization requirements are and things. So I know we're right at the top of the hour, but maybe time for one quick question. Anybody have a question for Rohit while he's on? Yep. Yeah. Yeah, so the question is K3S available in S390X? Yes, it is available. It is provided it's available to the community. Anybody can deploy it. Yep. Good question. Thank you. All right, and with that, I think we'll go ahead and wrap it up. Thank you, everybody, again. Enjoy your lunch and enjoy the rest of your time.